All right, today we're going to dive into a concept that has totally changed the game for Swift developers, protocol-oriented programming. We're going to see how this powerful way of thinking lets you break free from the old traps of object-oriented design.
So let me ask you this. Have you ever been stuck deep in a web of classes where you change one little thing over here and a dozen things break over there? Yeah, it's a super common frustration for developers, and it's exactly the problem we're going to tackle today.
Look, for decades, object-oriented programming, or OOP, has been the king. And for a lot of good reasons, right? It gave us structure, gave us reuse, but it has its limits. And one of the biggest ones is a nasty pitfall I like to call the inheritance trap.
Think about classic inheritance like a really rigid family tree. A class can only have one direct parent, and it gets everything from that parent and its grandparent all the way up. This creates these deep, brittle structures that can make your code fragile and honestly a total nightmare to change down the road.
But this is where Swift comes in with a much more elegant solution. Instead of being locked into that rigid family tree, Swift encourages a whole new way of thinking, protocol-oriented programming, or as we'll call it, POP.
So, what is it exactly? Well, at its core, protocol-oriented programming is all about defining behaviors using protocols. Your types, and this could be structs, enums, or classes, they just adopt these behaviors. And here's the magic trick. You can add shared functionality to all of them using something called protocol extensions.
And this quote right here, it nails the entire philosophical shift. This is the crucial difference. We stop worrying so much about what a type is in a hierarchy, and we start focusing on what it can do. It's a move from identity to capability.
Okay, theory is great and all, but let's get our hands dirty and see how this actually works. We're going to use a super simple example, creating a drivable behavior that we can apply to completely different kinds of things.
Step 1, we define the capability itself. We create a blueprint. You can think of it like a contract that just describes what it means to be drivable. Now, this contract doesn't say how something drives, just that the ability to drive has to exist for anything that signs on the dotted line.
Now this is where the power really kicks in. With an extension, we can provide a default shared implementation for that drive method. So now, any type that agrees to our drivable contract automatically gets this functionality for free, without writing a single extra line of code.
And this is where you see the incredible flexibility. We can take two completely unrelated types, like a car and a bike, which could just be lightweight structs, and simply say, hey, you're drivable. They don't need a common parent, they don't share any history, they just adopt the behavior.
And just like that, boom, both our car struct and our bike struct can now be told to drive. They share a behavior without being forced into some clunky inheritance chain. It's exactly like playing with Legos. You just compose the functionality you need by snapping on different behavior bricks.
All right, now that we've seen POP in action, let's put it in the ring with traditional OOP to really hammer home the differences. Let's get ready for the showdown.
On the most basic, fundamental level, OOP is built on inheritance. That is a relationship. A poodle is a dog. POP, on the other hand, is built on composition. It's a can-do relationship. A car can do the drivable thing. It's a subtle but really profound difference in how we build our code.
So let's break it down. You can see how POP just shifts the entire focus away from rigid class hierarchies and towards flexible behaviors. And for code reuse, instead of being locked into inheritance, we get to use those awesome protocol extensions and composition. But for me, the biggest win here, the real game changer, is the flexibility with the type system. POP works beautifully with lightweight structs and enums, not just classes, and that's a massive advantage in modern Swift.
Okay, so we've covered the what and the how. Now for the most important question of all. Why does this actually matter, and when should you be reaching for this in your own projects?
So the wins here are pretty huge. You get code that's less tangled up, more modular, and way easier to test. It really encourages you to use those lightweight value types, which is great for performance in Swift. Plus, it just elegantly solves some classic OOP headaches, like the dreaded diamond problem, where a class inherits conflicting methods from two different parents. With POP's composition model, that entire problem just vanishes.
So when do you pull this tool out of the toolbox? Well, definitely when you need to share behavior across types that just don't fit into a tidy class tree. It should absolutely be your go-to when you're working with value types like structs and enums. And really, anytime you want to build an architecture that's flexible, super clean, and easy to test, POP should be the first thing on your mind.
You know, at the end of the day, the goal is always to write better code. By embracing protocol-oriented programming, you're really setting yourself up to write code that's safer, way more reusable, and just a lot more predictable, especially as your projects get bigger and more complex.
So I'll just leave you with this question for your next project. Instead of immediately asking, what should this object inherit from, maybe the better question to ask is, what can this object do? Maybe it's time to start composing.